We'll analyze in this particular session single line to ground fault on unloaded generator. And we're analyzing a single line to ground fault on the unloaded generator. That you have to very carefully observe here. It is unloaded generator. For that, I am considering here the diagram or solidly grounded unloaded generator when there is a line to ground fault occurs. Now I am considering there is a fault is occurring on phase A. I am considering the fault is occurring at phase A. The before the fault occurs, the generator is under unloaded condition. Therefore, before the fault, the prevailing conditions are the IA, IB and IC all are 0 because it is unloaded generator. Then at the same time, when it is unloaded, the terminal voltage VA, VB and VC are equal to their corresponding voltage, that is EA, EB and EC. Okay, with this note, just you have to analyze the single line to ground fault. The first, the system to be analyzed is shown in this particular figure. That is all the three phases I drawn here for a generator with it is a solidly grounded with Zn here. Let the fault is taking place on the phase A. I am considering the fault is occurring here. Fault is occurring. When there is a fault occurring at this particular point, then what are the boundary conditions? Means what are the terminal conditions for this particular generator? That is, we know that there is a before the fault IA is 0, IB is 0, IC is 0. But when there is a fault occurs to the ground here, then there is a fault current is flowing. Therefore, the fault current in this case IF is nothing but your IA. However, the current in the B and C still they are 0 because as such there is no connection here. Therefore, still IB and IC are 0. That is one condition is the IB and IC is equal to 0. And the another condition, whenever there is a fault occurs here on the phase A, the terminal voltage VA is become 0. Because I told you in the shunt fault, whenever there is a shunt fault occurs, in that case, the current goes very high, whereas the voltage is become 0. Because the fault is occurring at the terminals of the phase A, therefore VA is become 0 and the fault current IA is equal to IF, whereas IB and ICs are both are 0. The same, the boundary condition I am written here, VA is equal to 0, IB is equal to 0, IC is equal to 0. Based on this is fault current, IB and IC they are all 0 and the voltage VA at this point is 0. The same, the boundary condition I have written here. With the boundary condition IB is equal to 0, IC is equal to 0, symmetrical components of the current. It is a symmetrical component I am expressing in terms of the unbalanced phasor, that is here actually it is IA, IB and IC here. IB and IC here. But we know that IB and IC are 0. These are two are 0. Therefore, I am substituting here 0 value. This is IA0, IA1, IA2. It is 1 by 3, 1, 1, 1, 1 A square, 1 A square A, 1 A square A. Then it is IA 0, 0 because I am putting here 0 because IB and ICs are 0. IB and ICs are 0. Now, if you are calculating IA0 from this, then what I am getting here is the IA0 is 1 by 3, 1 by 3. That is, you have to multiply this and this. That is, it is 1 by 3 is a common multiplication factor. That is 1 into I is I. Similarly, if you go for IA1, if you are going for IA1, you have to 1 by 3 is a common. Then what we are getting is you have to multiply this and this. Second row, this column. That is, it is 1 into 1, IA is IA, that is IA. Then it is A into 0 is 0, A into 0 is 0. Therefore, you are getting 1 by 3. Similarly, if you are going for the IA2, once again you have to go by this and you have to go by this. That is, It is 1 in 1 by 3. It is IA. Then A square into 0 is 0. A into 0 is 0. Therefore, I. Then what you are observed here as all IA1, IA2 and IA naught, they are equal to 1 by 3. IA by 3. That is what I am written here. That is the value of IA naught, IA1 and IA2 is equal to IA by 3. What I am observing, when there is a line to ground fault occurs, the what I am getting here is the value of IA naught, IA1 and IA2, they are all equal, then that is equal to IA by 3. That is the condition I am getting, but that is the value of IA naught, IA1 and IA2. Then if you are putting in the voltage equation of the network equation, I told you the network equations, they are VA naught is equal to minus IA naught Z naught. The same thing you are getting from this particular matrix, that is VA1 is equal to EA minus IA1 Z1 and VA2 is equal to minus IA2 Z. Same thing you are getting here, that is it is 0 minus Z0 into IA0, Z0 into IA0 with a minus sign here. That is what I am getting is these three equations are written in this matrix form. Ultimately VA0, VA1 and VA2, what we are getting is IA0, Z0, IA1, Z1, IA2, Z. Just you have to look into the value of IA0, Z0, IA1, Z1, IA2, Z2. Just I am putting here, substituting the value of IA0, IA1, IA2 in the above equation we obtain. That is, based on this, you are written this. Okay. That is, if you are realizing this particular, realizing this equation, that's VA0, VA1, VA2, that is what I am getting here is, just now I rubbed it off. That is, once again I will write, that is VA0 is equal to minus IA0 Z0. The same equation we are getting from this, if you are realizing this. That is VA1 is EA minus IA1 Z1 and VA0 as VA2 it is IA2 into Z2. Then we know IA0, IA1, IA2 all are equal. That is, we are already derived that. That is, IA0 is equal to IA1 is equal to IA2. Therefore, what I am doing here is, I am replacing all IA0, IA1 in terms of IA1. I am replacing IA0 and IA2 in terms of IA1. That is, I am replacing IA0 and IA2 in terms of IA1. I'll tell you why exactly we are transferring this. Therefore, I am writing VA0 as it is IA1 Z1 minus IA1 Z0. This is as it is, the same, whereas this can be written as minus IA1 IA2 Z2. Means I am replacing IA0 by IA1. I am replacing IA2 by IA1. Okay, therefore I am replacing all IA0 and IA2 in terms of IA1. Then I am getting this equation. These are the equations what I am getting here. That is minus IA1 Z0. This is VA1. These are the sequence voltages in terms of IA1 I am getting. Then you have to make use of the boundary condition, that is VA0 is equal to 0. That is, you have to write the equation for VA, that is value of VA is VA1 plus VA2 plus VA0. And thus the VA is 0. The same thing I am written here, that is VA0 is equal to 0. Now you have to substitute the value of VA1 VA2 and VA0 in this. The same thing I am putting here. That is VA1 is EA minus IA1. This is a VA0. This is VA0. VA0 is IA1 Z0. IA1 Z0. IA1 Z0. Then the VA1 is as it is. VA1 is as it is. Whereas VA2 is minus IA1 Z2. That is this VA2. VA2 is minus IA1 Z2. Everywhere it is replaced by IA1 Z0. It is A1 I1 Z0 Z1. VA2 is minus IA1 Z2. The same thing I am putting here. VA0, VA1 and VA2. Then here what I am getting here is the IA1 is a common in this. The IA1 is the common in this equation. If you are looking into this equation and this equation, you take the IA1 common, then you transfer the EA1 that side. Then what I am getting here is I'll write down here, that is better. You can, how we are getting here, this is I am getting here minus IA1 I will take common. Minus IA1, that is Z0, that is Z1 and Z2. And this plus EA I am transplanting to other side, that is minus EA. Both side negative get cancelled. Therefore, then what I am getting here is IA1 is equal to EA divided by Z0 plus Z1 plus Z2. Z0 plus Z1 plus Z2. That is, my main object is to find out what is the fault current, and what is the terminal voltages VA, VB, VC under fault condition. That is why I am doing all these exercises. What I did, first I am taking the symmetrical component of current and the boundary condition I am putting here. The boundary conditions are putting for the current sequence. Then I arrived at this value. That is IA0, IA1, IA2. Then next I am using the sequence network equation here. That is VA0, VA1, VA2. Then I am putting these condition IA0, IA1, IA2 all are equal. Then what I am doing here is the IA2 and IA0 I am expressing in terms of I1 in this equation. That is whatever the equations I have got for zero sequence network. That is, this is a zero sequence voltage. Here it is IA0. It is a positive sequence, you are retaining as it is. Here it is VA2 is IA2 Z2. This IA2 I am replacing by I1 because I am taking only one unknown, because there are three unknowns, IA1, IA0 and IA2. Instead of that I am making only one unknown. Therefore that is IA0 is equal to I1, IA2. Making use of this condition, all IA0 and IA2 are replaced with IA1. Therefore, what I am arriving here is the value of IA1. I am getting here the value of the IA1 here. We know that the fault current is IA. The fault current is IA is nothing but our fault current. What is that? That is, the fault current IA can be expressed in its symmetrical components IA1, IA2 and IA1 and IA2. Okay, then we know that IA1 and IA2 everywhere it is same. That is, I will call it is IA0 plus IA1 is also I will put as IA0. IA2 is also I am putting as IA0. Therefore, what I am getting is 3 times IA0. Therefore, what I am getting is, here it is 3 times IA0. That is also equal to 3 times IA1, because IA0 and IA1 are one and the same. Ultimately, why I am expressing the fault current in terms of 3 times IA0 is that is one statement you have to remember. Whenever the fault involving with the ground, then the fault current is always 3 times IA0. When the fault is involved with a ground, then the fault current will be 3 times Ia naught. Okay. Therefore, the fault current what I am getting is Ia is equal to 3 times Ia1, or it may be 3 times Ia naught also. Okay. This is the fault current as far as the calculation of the fault current. Then how to find out the terminal voltage VA, VB, VC? How to find out the value of VA, VB, VC? That is very simple. That is, to get VA, that is you have to, it is VA naught plus VA1 plus VA2. That of course in this particular case VA you have to get 0. Then VB is equal to VA naught plus A square times VA1 plus A times VA2, and VC what I am getting here is VA naught plus A times VA1 plus A square times VA2. I know the value of the Ia1, Ia2 and Ia naught. Therefore, easily you can calculate what is the VA naught, VA1. I will put it here. That is, I am making use of another page itself. That is better. Just I will create one more. Okay. Here I have to find out, one is the fault current you are already calculated. Fault current is equal to 3 times Ia1. That is nothing but 3 times Ea divided by Z0 plus Z1 plus Z2. And you have to find out the phase to line voltage of VA, VB, VC. VA, VB, VC. That is VA naught plus VA1 plus VA2. And VB you have to calculate as VA naught plus A square VA1 plus A times VA2, whereas VC is VA naught plus A times VA1 plus A square times VA2. This is how we have to calculate positive, VA, VB and VC. Then what is the value of VA naught? That is very simple. VA naught is minus Ia naught Z naught. The Z naught is a given value. Ia naught we know, that is, we know Ia naught is equal to Ia1 is equal to Ia2 is equal to Ea divided by Z1 plus Z2 plus Z0. Already were calculated. All are equal here. Therefore, the VA naught can be easily calculated. That is, VA naught is equal to minus Ia1 into Z0. Similarly, you have to calculate what is the VA2. VA2 is minus Ia1 Z2, whereas VA1 as Ea, that is, it is under no load condition. The VA is equal to Ea, that is equal to 1 per unit. That you have to take it as a 1 per unit. That you have to remember. Under no load condition, without the fault occurs, when there is no fault occurs here. Therefore, VA1 is equal to minus Ea, it is Ea minus Ia1 Z1. Because we know the value of Ia1 were already calculated here, and we know the value of these are the given quantity, that is Z0, Z2, this is Z2, this is Z2 and Z1. All these are quantity or given quantity, Z0, Z1, Z2. Whereas the Ia1 value were calculated. This is how you have to find out the VA, VB, VC. Once we know the value of VA, VB, VC, then you can calculate the terminal voltage, that is VAB, as VA minus VB. Of course, it is a vector difference. These are also vector sum. Okay, whereas VBC can be calculated as VB minus VC, whereas VCA can be calculated as VC minus VA. This is how we have to find out the terminal line to line voltage under fault condition. One is the fault current IF, that is equal to 3 times IA1. Then you have to find out VA, VB, VC by calculating VA0, VA2 and VA1. Then thereafter you have to find out the terminal voltages between line to line VAB, VBC, VCA. Okay. Now once again you can recall here for line to ground fault, here IA0, IA1 and IA2 are all equal. If the current which is flowing in the system have got a same magnitude, means the three networks are connected in the series. Three networks are connected in series. The meaning is that the positive, negative and zero sequence network of the faulted generator is connected in series. That is, I am shown here. This is your positive sequence network, negative sequence network, zero sequence network. They are all connected in series. See here, the current here is IA1. The current in the negative sequence is IA2. IA2 is equal to IA1 because we are already derived that it is IA0 is equal to IA1 is equal to IA2. And we have got a zero sequence network here. The current which is flowing is IA0. Once again, IA0 is equal to the IA1. IA1. See here, all they are in the connected in the series. The same current will flow here. These are the series current. Therefore, the current in the series network is IA1. The current in all positive, negative and zero sequence is IA1. IA1 is equal to IA0 is equal to IA2. All are equal. Therefore, the sequence networks in the case of line to ground fault, they are connected in series. They are connected in series. Therefore, the summary is that IA0 is equal to IA1 is equal to IA2. Therefore, the positive, negative and zero sequence networks, they are connected in series, and the fault current is given by 3 times IA1, and the terminal voltage you have to calculate, that is a per phase voltages, that is VB and VC of the under fault condition you are calculating. Thereafterwards, if you know the VA, VB, VC per phase value, then you can calculate the line values, that is VAB, VBC, VCA. To calculate VA, VB and VC, that you have to calculate VA0, VA1, the VA2, that can be calculated here. VA0, VA2 and VA1. Just you have to substitute these values in these equations, then you are getting VA, VB, VC. Once you get VA, VB, VC, then you can find out VAB, VBC, VC. This is how you have to analyze the fault current, the fault voltages at the terminals when there is a line to ground fault occurs.